Welcome to today's lesson. Come to Next Minds Academy. We do offer online lessons basically through Zoom. All you need is a smartphone, access to Wi-Fi, then plus the Zoom app. Your email address and earphones are very important. Always give an ID and password for all our lessons that we always have. Indeed, we are very sure that you'll enjoy our lessons. Next Minds Academy, Indeed Learning starts with us. For today, we are basically going to look at Archmides' principle, and it states that when a body is wholly or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of the fluid that is displaced. So under normal circumstances, when a body is placed, it can either be totally it means it will be completely underwater. Then if it's partially, it means part of it is underwater, whereas the other part remains floating in a liquid. So when that body is totally or partially immersed in a fluid, its weight basically changes. This can be observed like when you try to carry, let's say, if it is a jerry can in water, and when it's outside the water, when it is in water, it appears to be heavier than when it is being carried in the water. So it loses weight basically, and that effect of it weighing less is caused by what we call upthrust. So meaning that when it is in a fluid, it experiences upthrust. So upthrust basically, it's the force that always acts upwards in a fluid, and it is defined as the apparent loss of weight by a body that is placed in a fluid. So upthrust is the apparent loss of weight of a body that is immersed in a fluid. So among the terms in Archimedes' principle that we have talked about is upthrust, which is a force in a fluid that basically acts to push the body upwards to make it appear to weigh less. And then the apparent weight is the weight of the object in the fluid. So let's look at the experiment to verify Archimedes' principle. So in this experiment, we have a displacement can. We require a displacement can, or call it a eureka can. Then we need water. We need a light and thin string, and a spring balance is also necessary. And a suitable solid, I think we shall use a stone plus also a beaker. So the procedures that we shall follow: we fill the displacement can with water till the water flows through the spout, and we shall wait until the water ceases or stops dripping. So the solid is suspended using the light spring from the spring balance, and then we record down its weight in air. So we suspend it from the spring balance such that we can get the weight of the solid. Afterwards, we place the beaker of known weight under the spout of the displacement can. Then after, we immerse the solid in the water in the displacement can and wait until the water ceases dropping in the beaker. So that is clearly shown in this diagram. So we now record and record the apparent weight. So basically we take the second reading after the weight is placed. So after the solid is placed in the water. So we also reweigh the beaker and the displaced water. So we record our results. So the weight of the solid in air is recorded as WA. Then the weight of solid in water, which we call the apparent weight, after placing the solid in this water, we record it, we denote it as this. And we also weigh the empty beaker as this. Then the weight of the empty beaker plus the displaced water is also recorded as this. So you realize that if you are to find the upthrust, which is the loss in weight by the solid when it is placed in a liquid, we shall get the weight of the liquid in air, so the weight of the solid when it was in air, then we subtract the weight of the solid after we've placed it in the water, which will be WA minus W, as you can see here. So when we weigh the weight of the water that is displaced, this will be got by getting the weight of the beaker plus water minus the weight of the beaker. This is the water that was collected here. So if we take its weight, we shall get an answer as this. So if you compare these two answers here, you realize that the two will be equivalent. So since this is the weight, this is the weight, or this is the apparent loss of weight of the solid when it is placed in the water, and this is the weight of the water displaced. So we therefore conclude that that the upthrust is equivalent to the weight of the fluid displaced, and therefore this verifies Archimedes' principle, which says that when a solid is partially or wholly immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. Okay, so let us try to look at how this can be done. The materials that we require are Eureka can, stone, beaker, measuring jar, and spring balance. Those are the materials. So practically, this is how it can be done. So we arrange the Eureka can as it is shown with the beaker on table. So we pour water until it starts coming out of the spout, and then it settles until it stops coming out. So now we can replace this beaker here with a beaker of known mass. Remember, we shall use the mass. So we are now suspending the stone with a spring balance such that we get its weight in air, that is before placing it in the water. So its weight is recorded. You can see here the weight is 20. So we now lower the stone into the Eureka can, which has water. So we now record the reading of the spring balance, which will be the weight of the stone in water. So you realize that the weight reduces, which is, and read 17, meaning that it has lost some weight when we've pressed it in a liquid. So the weight basically is less than the weight in air, and it's less by 3, as you can see here. So when we placed the stone, connected to a spring balance, some water was displaced and collected. So when we take the weight of this water, we realize that the weight of the water is 3. The weight of the water is 3. So 3 is equivalent to the apparent loss of weight. So the water displaced has the same weight as the apparent loss of weight of the stone placed in water. So from here you can see that upthrust is basically equal to the weight of the fluid that is displaced, and this clearly verifies Archimedes' principle. So from there, we conclude that Archimedes' principle states that when a body is wholly or partially immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced, and it has been clearly verified practically. Okay, thank you. Have a blessed day.